At time t equals 0, a particle P is at the point with position vector 30i plus 35j meters, relative to an origin O. P moves so that r double dot is a constant and equal to 3i plus 4j. So we have r double dot is equal to 3, 4. When t is 0, r dot is 0. So in part A we want to find the vector r dot when t is 4. So we need to integrate 3t plus a constant, 4t plus a constant. Now, when t is 0, r dot is 0. So the 0 vector, as we can see here. So t is 0, so that's just c1, c2, so those constants are 0. R dot then is 3t, 4t. So r dot when t is 4 is going to be 12, 16. Now for distance we want the displacement vector. Now, so we want r, of course I should be underlining all these r's because they're vectors. So we need to integrate r dot. So that's 3t squared over 2 plus a constant. 4t squared over 2 is 2t squared plus a constant. And we know initially it's at this position here. So 30, 35 is going to be equal to, these will be 0, so c3, c4. So that means that r is going to be 3t squared over 2 plus 30 and 2t squared plus 35. So r of 4, because it was at this time they said, is going to be, so 4 squared is 16, divided by 2 is 8, so that's 24, add 30 is 54. And then this is 16 times 2, 32, add 35 is 67. So our distance, just using Pythagoras, is 54 squared plus 67 squared. We just need to calculate that. So that's the square root of 54 squared add 67 squared. And that's really not a very interesting number. So we'll make that 86.05 meters correct to 2 decimal places.